because we have a nice example. I think it's good to talk about real projects, and then you guys give feedback on these specific things that we're working on, and ask questions as well. So there's a centrifuge project which Jans can show up a bit, and there are basically two sub-projects, right?
Yeah.
So yeah, he can talk about it, and
So let me unpack this.
just raise your hands, because this is now just discussion and ideas, so that we get feedback and you also get a feeling of what is actually happening, right?
Yeah, so my name is Jannes. I have been working with Jose on this little machine since end of May, beginning of June. It is a microcentrifuge, and what it does, you have vials with a sample in a Wetlab. Jose's wife works in a Wetlab here in the TU, and they have to separate materials in these samples by spinning it very quickly. Now, these machines normally are very expensive because they are proprietary designs, and well, laboratories can only buy these very expensive machines, and they depend on the producers of these machines. So we started working on this machine, which is based on the design of a student in Stanford, actually. It works now. I can hook it up somewhere, maybe and show it. But it's just a first model, and it's like a toy with with wood and a plastic sheet. But it spins up to, I think, about 100 rotations per minute.
9,000 RPM.
Yeah,
Yeah,
so
yeah.
much already. The thing is, it's all made with an Arduino, and that's a screw because I was working on it this morning. The thing is, this is just the first step, and we have a lot of ideas in how we can improve this. Yeah. And we have also bigger industrial machines that we can work on. So now it's a very small machine. It has a small motor that we found online that was actually made for to fly a drone, but we want to put a bigger motor in there. It needs to be fastened. There are all these small tasks. That's what Jerry said. We have a whole bunch of small tasks that we need to do to improve this little machine to make it more suitable for an actual Wetlab. So we need to improve the motor. I am an industrial designer. I only work on this 1 day a week. I don't know too much about coding or electronics, so if anybody can help with that, to put our new motor in our centrifuge, that would help out a lot. We now have it running at 9,000 RPM, but we really want to have it go to 13,000 RPM, so it needs a little bit more safety mechanics. Now when you open the lid, the motor shuts off, so that, but we need way more safety measures to be built in this little machine when we have a motor that runs up to 13,000 RPM. We want to install a cooling in there, but we don't know whether the thing that we have works very well. We have all the specifications of our J element and fans online, and you can just look it up, and maybe if someone's good with building simulations, simulate whether we can actually cool our small air volume here in time for our spinning files. Also, this is just one design with cutted sheet. We might want to make it 3D printable because that's a more simple machine than a laser cutter. And when you don't have access to a laser cutter, you might have access to a 3D printer. And we can see whether we can make this design fully 3D printable. We also want to be able to scale this. If you want to have more files in there, you should be able to change that easily. Also, if you have other parts, because we've bought these parts here locally. If you don't have this screen or some of these electronics inside, but you have other ones, you can maybe change dimensions a bit, and your whole machine changes. So you need to have special files that you can 3D print or laser cut. But still, this is a microcentrifuge. There's a lot of things that we want to do, and anyone who has just a a small bit of time and wants to help out can help us out here and find us through the website, I guess.
Yeah.
But with all the specifications and the design how it is right now, you can even build this one if you want, and then start improving on your own. But that's just our little small toy machine. These are the bigger professional machines that we have 3 or 4 of. Bas got them from the Erasmus.
Me.
You got them from the Erasmus hospital, and they're broken. There are 3 of them.
By the way, I want to just mention that it was thanks to the data stewards that we got these ones, because they say, you're doing the centrifuge, how can we help you? And then I asked, do you have spare broken centrifuge that we can analyze and tear down? And then you say, yeah. So they put me in contact with the Erasmus University, and we got 3 of those, so we have 3 of those to play with.
Yeah, and they're all broken. They don't seem to be broken in any structural part, but probably it's the electronics that are broken somewhere. We don't know where. We need it to be analyzed what is really broken. We also think that it's probably the same thing that's broken in all 3 of these machines. So if we can find out what part is broken and we can fix it, we can make a repair guide for people who have this machine and it breaks down. They can repair it themselves and use it longer. Also, what we want to do is there are a lot of nice parts in this. If you just know all these simple electronics here, and then there's this nice machine, well built, but it's broken because of some electronic failure. Maybe we can reuse these parts and make even a better machine that also works better than this little toy machine here. So this is also some thoughts that you can help with. If there's anything that you'd like to do a failure analysis. The machines are in the IDE faculty. You can maybe help write a repair guide if we've found what the problem is, and then you can help.
Yeah, I also got the feedback from the guys that they sent the machines to the company or something, and the company said that they were not going to fix them because it was electronic failure. And another question is, can we make a module for this? If there is enough demand or enough amount of these machines broken, can we have an electronics module developed with open hardware components to reuse these machines? Because these models are very expensive and very good high-end motors, as well as the rotor, which is completely milled. So that is another task to work on. Then it would be nice also to share with for instance, with Bas and professors that are interested in getting into more serious repairability and using open source to have an impact industrially. That is something nice to think about. But there are many opportunities on this case of the centrifuge itself. So it's just an example of how many people would join in with their own expertise to make it better. So but these are just some good examples of things that need to be improved, because currently we are in a very initial stage, and that is really cool because then you can actually contribute and make substantial improvements.
If you have some skills that you might be able to use, help us out, or help everyone out here, because it's not just our problem. Please do so. Find something in a website. And,
or ask them directly or whatever. We have. I think I mentioned already, but every Friday we meet in the lunch break to meet new people and try to get them onboarded and find the way to successfully contribute in one of these projects. So, does anyone have any idea or comments or criticism so far? Is it interesting? Yeah.
Well, I would be curious if the manufacturer of the machine wouldn't object to it being repaired for safety reasons.
That's a good question. The thing is that they are going to be disposed because, it's the problem. And we have 3. So that's. I don't think they can object against people fixing that machine. I don't know, but I think you guys know more about this issue than.
Well, then there are some issues with high voltages and high currents over there, and if you just misfix it, then suddenly you can go up into flames at a certain point.
Yeah.
Then you have liability issues. Not only liability, it's not very healthy for anybody.
Yeah.
So it's very difficult to find where is the water line, where can we work, what can we do, what can't we do.
Yeah. So do you think, for instance, it would be more feasible to develop a complete modular electronic that substitutes this one versus repairing something that we don't know how it was designed?
I think we first have to find the failure.
Yeah.
So that's where we need electronics people for. I don't know if you ask marketing applied labs for that. Look into this.
Yeah.
Because there are some diagnostics methods or ways to go through this and see where problems can be found.
Yeah.
It's based on people who are very well experienced.
Yeah. Yeah.
But I'm not experienced.
Yeah. Yeah.
None of these.
Okay. So, yeah, that's an example of a project. There is another one coming up